Hello, we're going to be looking at an activity using congruence and CPCTC, which is the focus of this week's lesson in geometry. We will be determining the postulate that proves why each pair of triangles are congruent. And so we have the 5 postulates listed down here. These capital letters stand for the parts of the triangle. A is angle and S is side. And so in each diagram, we're going to look at the markings, and we're going to notice in this first pair of triangles that, okay, there is a side in this triangle that is congruent to a side in that triangle. We're also going to notice that there is a right angle in each triangle. So we're wondering, could it be hypotenuse leg? Well, there also is going to be a side that they share. This hypotenuse is a side that they share. So once you've established the parts of the triangles that are congruent, because you're looking at the markings, we go around the triangle and we say the parts. So I might look at this right angle, which is congruent to that angle, and I might say angle, side, side, because I go in order as I say those parts. Or I might start here and say side, 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 angle. Well, there is no such thing as angle, side, side, or side, side, angle. So what we do instead is we look at the fact that, oh, these are right triangles. And there is a hypotenuse that is congruent in both and a leg. So we will be using hypotenuse leg. So angle, side, side, and side, side, angle is not a legitimate postulate. The second pair of triangles, I see that there is definitely a side in each that is congruent because of that single tick mark. And there's another side that's congruent in each. And the other thing that you want to always be on the lookout for are vertical angles, because vertical angles will always be congruent. So as I read the parts, we always start somewhere at the edge. We say what the part is, we say that part, and we say that part. I'm going to say side, angle, side. Or I could have said it up top, side, angle, side. So that's what we're going to be using to prove these triangles are congruent. Now we go on to the last one, and we notice that it's another right triangle. So, but hypotenuse leg is already used, so it's going to be something else. There is an angle that they each have that's congruent, and another angle. And don't forget that side that they share. So we're going to start down here, and we're going to say this part. Angle, angle, side. Angle, angle, side. So that's what we want to get a lot of practice with, is identifying which postulate proves the triangles are congruent. We'll hit OK. We'll notice we got that right, and then we're going to move on. CPCTC, we've been talking about this, is corresponding parts of congruent triangles are congruent. That's what it stands for. Because of CPCTC, when we know that a pair of triangles are congruent, we can identify that corresponding parts will also be congruent. By corresponding parts, we're talking about angles or sides. So here we have a statement that triangle CAN is congruent to triangle TRY. By CPCTC, we can state with confidence that angle N, which is the third letter in this triangle's name, is definitely going to be congruent to angle Y. That one we can check off. Now let's check out this one, angle A and angle R. Well, A is the middle letter, R is the middle letter. That works. Now let's look at the sides. What about side CA? It's the first 2 letters in this triangle's name. What about side TY? That's the first and the third letter, so we're not going to select that one. Let's look at AN, the last 2 letters, and RY, the last 2 letters. these sides are definitely going to be congruent. Now we look at this, and we're going to ask you to interpret this congruent statement and select all that would be correct. Remember, the order matters. Hopefully you recognize that angles A and L are corresponding, so they are congruent. Angle G and R are not corresponding. G is the third letter, R is the middle letter. They are not necessarily congruent. Side RA, first two letters up here, and EL, first two letters, they're corresponding. Those sides are congruent. MR and LE are not corresponding. MR are the last two letters, LE are the first two. Don't select that. And let's hit OK. Now here's our proof. And in a two-column proof, we always will be, or usually are given a diagram. There will typically be some given information in words, and there will also be information in the diagram itself regarding tick marks that show things that are congruent. And there will always be a statement that says prove something. That's what we're trying to prove. That always goes at the very bottom. And the given information always goes at the very top. So it's given that sides EF and DE are parallel and that segment EF is congruent to segment GD. We also can state, because these lines are parallel, and let's just remind you that when we have parallel lines like this, and these little arrows indicate that these lines are parallel, we can look at either one of these lines as a transversal. So let's look at this line as a transversal that passes through the two parallel lines. And because of this transversal, we know from our earlier work that alternate interior angles are congruent. Similarly, on the other side, that transversal would force these angles to be parallel. And finally, we know that there are also a pair of vertical angles that are congruent. So there's a lot of directions we can travel in this proof. Let's see where the author is taking us. HEF. HEF is congruent to HGD. That's by alternate interior angles. Triangle, EHF. So then we're going to look at triangle EHF. EHF is this triangle, is congruent to GHD, and it must be congruent by angle, angle, side. And so the reason why it's angle, angle, side is this angle, which is vertical, this angle, which is alternate interior, and that side. And finally, HD, last two letters, congruent to side HF, last two letters, by CPCTC. Hopefully you feel like you are going to have success completing the rest of this activity.